Well, hello and greetings from northern Michigan. This is Bob the Science Guy with a very special show today. This is the fifth show in our Flat Earth Can't Science series. And today we're taking on one of our favorite flat earthers with a special perspective on the perspective of Phuket word. That's right, folks. We're finally getting around to analyzing the version of perspective used by Phuket word and spread all over the internet by his adoring fans, despite the fact nobody picks up on the carnival tricks that he employs, nor the obvious misunderstanding he has on this relatively simple subject. This is actually an analysis of two of his tapes, and you can see the links down below. Some of his claims include that perspective makes the sun go below the horizon. He seems to have a basic misunderstanding of eye level, horizon, and vanishing point, and seems to believe they are the same thing. And the other interesting thing is that he seems to feel that perspective applies in some situations, but not in others. Now, another claim that he constantly makes is that the horizon always rises to eye level. That's going to actually be handled in a supplemental video due to time constraints. I'm going to address that when I go up to Marquette next week and get some videos of the horizon over Lake Superior. So keep an eye out for that. It'll be posted below when it's ready. Now, you're going to want to watch this video all the way through because at the end I'm going to demonstrate how he employs the techniques of a shell game to fool his gullible subscribers. Now, the format that I like to use is to show a section from their own video and let them dig themselves a hole. So without further ado, here is Phuket Word discussing perspective.
Here's an excellent example of perspective. We can see straight away that these railings, although we know they would be parallel to the surface that we're looking across and that it's a relatively flat, although uneven surface, these lines, these parallel lines appear to sink towards the horizon created by the surface because of perspective. So this is the kind of view that we always have across the Earth. It's always from a very low perspective. And we know that perspective causes anything above our eye level going off away from us in a parallel line to our line of sight will appear to sink towards the center of our field of view. And that likewise for anything that's below our line of sight. So this floor is below the line of sight here and appears to rise up to the eye level somewhere in the center. Of course, we know that if we have a side-on view of railings on a pier like this, then those parallel lines will never appear to meet. That when we have a view like this, that what we see is parallel lines that never actually meet, they only appear to meet. So we can, for example, illustrate the sun making its way across this image in a kind of parallel direction to the railings or to the surface here. But if we were on the surface and the sun was above us, we know that it wouldn't appear to maintain this consistent height. Here we'll just show how the railings appear to be and the floor. If our line of sight is right here, in line with this middle railing, if we were on the pier, looking down along it this way, those railings would appear to sink down towards our midway point in our field of view, and the floor would appear to rise up, although we know this isn't physically happening. So we know that parallel lines going off into the distance, or something parallel to our line of sight going off into the distance, is going to appear to converge in the distance, in the center of our field of view. This is perspective and how it works.
Okay, so far he's doing pretty good explaining perspective. Now here's an excellent photo from Miles Davis. You see this rail that we have to our left? Our eye level is at the middle rail, and as you see, that goes down to a vanishing point marked by that small arrow. Notice that that is actually above the horizon of the pavement in the playground here. Yet on top, we can see buildings far beyond this in the background. Now, the reason it is important to understand this is that that top railing will never go below our eye level all the way out to the vanishing point. Likewise, the bottom railing will never come above our eye level all the way out to the vanishing point. And in certain situations, like on the real world where we have a curved surface to our Earth, our horizon is actually closer than objects that we can see over the horizon. The way that I'm going to prove this to you in the supplemental video when I go up to Marquette this weekend is I'm going to bring along spirit level with me. I'm going to level that object, and then I'm going to sight along the top of it, and you will see that it will go out into the sky. I will then raise the end nearest my eye until it lines up with the horizon, and you will see that the level demonstrates that I am looking downward. Now you can stay tuned until I post that next weekend, or you can just go out to a body of water that has a horizon on it and try it for yourself with a spirit level. You'll see the results are exactly as I described. Now, back to Nick's example. As I said, he was doing a pretty good job with perspective so far, especially the side view where you don't see this line of perspective converging to a vanishing point. But then he starts to go off the rails. Have a look.
So if we just take this further and illustrate what we would be seeing if we were stood on the pier right here, where that seagull is or something, what we would see as the sun goes off into the distance, maintaining a constant height above the surface, is the sun appearing to follow this line of perspective and meet somewhere in front of us with the surface. That's what it would appear to do. Of course, we know it's not doing this, but this is the only way we can illustrate this, what the observer sees from this side-on perspective. So we can illustrate this in this way. Back on the pier here with a sun following these lines of perspective created by the railings here, and we would see the sun eventually meet with the floor.
Okay, the key problem with his version right now is that note that the sun does not change in size as it gets further and further from us. That is not the way perspective works. You see these lines of perspective above and below the eye level, specifically above the top railing there. I've drawn a line of perspective from the top of the sun, which is riding along the top railing, all the way down to the vanishing point. As the sun gets further and further away from us, it will shrink to stay within that line of perspective and the top railing. Now, if you turn your attention to the side view in the upper left, you see the sun is riding along the top railing of that fence. It is all the same size, and it's just moving down the fence. When you look at it in the side view, this is what you would see. Now, in the view going down the fence, you have to identify these lines of perspective, and things must stay within their line of perspective to replicate how we would see things in the real world. Now, here we see the logical fallacy of the flat earther. He's going to claim that everything must be viewed in perspective, yet certain things don't have to follow perspective. We'll let him continue.
Now, people will argue about angular size and demand that the sun changes in angular size as it gets further away, just as we see the railings appear to get smaller and smaller as they go off into the distance. But isn't this a ridiculous thing to demand when we see these physical, tangible railings in front of us and this floor, a very short distance in front of us, maybe 100 or 200 meters, converging in the distance?
And there you have it. So according to Phuket Word, the sun doesn't have to follow the rules of perspective that everything else does, except we can use perspective to have the sun set. So this is an example of what he claims is happening, and you tell me whether or not you think this looks like what you see in the real world. So he's made this ridiculous claim, but watch him try and double down on it. Oh, recall one other thing. Not only does the sun stay the same size, it's the only object in this entire picture that can cross lines of perspective, go from above your eye level to below your eye level. It's the only thing that can do it. Now, our only conclusion will be that the sun somehow is special, or he's freely changing the rules to suit his narrative. You be the judge.
So, why should we expect the sun, which is an intangible light in the sky that lights up entire continents, why would we expect that to change in angular size at the same rate as we see this change in angular size due to perspective right here in front of us? That's just ridiculous. It's demanding the impossible.
Of course, it's absurd to expect lights to change in size with perspective. Oh, wait a minute. I think they are. What do you think?
As the sun goes off into the distance, it's going to appear to hit our horizon and converge in the center of our field of view. And of course, it will get cut off by the surface as it doesn't actually physically go down, it just continues off into the distance but appears to sink. It's perfectly acceptable for it to be doing this above a flat Earth due to perspective without changing significantly in angular size, because the distance that we can see across the surface before the surface cuts off the sun is relatively short compared to the distance the sun is going in the transparent sky.
Now, before we go on to his next wild claim, let's just review what real perspective in the real world looks like. We have these lines of perspective. One goes to the top of the sun, and the sun is sitting on the railing. As the sun goes away, it will become smaller and smaller as it stays within those lines of perspective. It will never go below our eye level, which is the middle railing. Now, Phuket originally outlined this accurately, and then he changed it in reference to the sun in what's called silly pseudo-flat Earth perspective to meet his narrative. So this is his explanation as to why the sun sets rather than the true explanation, which is it goes beyond the curve of the Earth as the Earth rotates. In the real world, the globe world, the sun is 93 million miles away. It maintains a steady 0.5 degree angular size throughout the day, including at sunset. This is due to its distance. Now, on the flat Earth, where we have a local sun, you would see perspective changes as the sun went away, as we are demonstrating in this photograph. Since indeed the sun does maintain a 0.5 degree angular size throughout the day, he had to create this exception to the perspective on the fly.
So we're told that the equator is actually tilted, and this tilt and spin of the Earth is what causes the seasons as it orbits the Earth in this direction, horizontally. So this is what we perceive is happening. I'm not advocating any particular model here, just to say that it's perfectly acceptable to perceive the sun doing concentric circles throughout the year above a flat Earth. We do not know the dimensions of that Earth, and it doesn't mean it's floating in space. This is just to look at what the sun's doing throughout the year. So in the winter it's doing a wide circle around the North Pole. In the summer and spring it's doing tighter concentric circles and then going out again as the winter comes around again. The sun over here is very far away. As it gets closer on its circular path, it will be at a point where it's closest to us, even if we're on the inside of the circle, and it will appear to be high above the horizon. Of course, if we are at the equator, then the sun goes directly overhead. But if we are away from the equator, then we'll only see the sun arc across the sky, simply appearing to get higher in the sky because it's getting closer to us and then appearing to get down towards the horizon again because it's getting further away.
All right, let's put on our critical thinking hats. Let's figure out on a flat Earth with the sun going around the North Pole where we would have to be on the flat Earth to see the top of this arc being the closest to us and each side being further away. Well, clearly we would be outside the orbit of the sun, with the center of that being closest to us, and the sunrise apparently there on the right, and the sunset on the left, both of which are further away from us. On the globe Earth, we would clearly be in the southern hemisphere if that is the sunrise on the right. Please also note in this photograph and the next one, the size of the sun is steady from sunrise to sunset. There is no change due to perspective in the size of the sun. Now we'll let Nick continue to show that even in the same view, some things follow perspective and others don't.
So we can just use this picture here to illustrate this. Of course, we can see perspective at play on the surface here. Everything appears to converge in the distance at the horizon. And this is a view that we would never actually have across the surface of the sun. Although this is what we can perceive is happening. The sun's going across the surface but maintaining a consistent height. But again, because of perspective, the further away it gets, the lower it will appear to sink towards the horizon. The higher it gets, then the more it will appear to rise to the horizon. And this is the kind of view you might have of the sun as it sets, goes off into the distance, and appears to get cut off by the horizon. Again, no need to demand that there is any change in angular size of the sun, because it's getting cut off very early by this very short view across the surface. The sun is in the sky going away from us. It's a lot further away than anything on the surface that's cutting it off before it gets very far away.
Now, of course, we all know that's not how real perspective works. However, I want to draw your attention to something else. I want you to start listening to the words and the language that Nick uses. You noticed in that last section that he told you what was the correct thing to think, and he also tried to short-circuit some of your questions. This is called NLP. It's conversational hypnosis. The other thing that you're going to hear from Nick an awful lot is he'll say, yeah, and it's generally after he makes a point. The horizon rises to eye level. Yeah. This is not a vocal tick or a pause that he is using. This is a NLP technique called a reinforcer. He tells you what he wants you to think, and then he reinforces it after a slight pause by saying, yeah. Now, in person, he would also put his hand on your shoulder or touch you somehow to again rivet this in to your mind that this is what you're supposed to think. Now that you know what he's doing, listen for him to use the technique during his video.
And again, we can have this kind of view. So this may be, we could be in the north, in say the UK or Europe, looking south. So east is over here with the sunrise in the morning, and as the sun gets closer, it comes up above the horizon. And again, we could be on the inside of this circle, but this is the effect we would see due to perspective, because there's going to be a point where the sun is closest to you, and that will be your midday, and it will be highest in the sky. Again, it's not going to go over your head, it's going to arc across the sky. So going from east to west, this is how you would see the sun behave in somewhere like the UK, looking south.
So notice this is the way the flat Earth is supposed to work as far as the orbits of the sun and the moon. Again, he got it wrong. You cannot see that view from the United Kingdom. You would have to be south of the arc of the sun in order to have the far ends further away from you and the midpoint closest to you. Notice too on this flat Earth map, it suggests that you see different phases of the moon on the same day in different parts of the world, because that's the way the flat Earth model works. That does not happen in real world.
And what you'll notice if you watch the sun and moon is that they both appear to follow very similar paths. Okay, we've noted that the sun will change its circular motion throughout the year, apparently getting higher and lower in the sky, creating the seasons, and we'll come back to that axial tilt in a minute. But essentially, if you watch the moon from any given location and you're fortunate enough to see sunspots on the sun, you'll notice that the sun and the moon appear to rotate and roll across the sky in exactly the same way. So this to me says that we are not in a position where the moon is orbiting us and we are orbiting the sun. Both are above the flat Earth, rolling around above us.
As a side note, in the real world, we orbit the sun and the moon orbits the Earth. Their orbits are not related to each other, and they change on a daily basis. They have completely independent tracks throughout the day and night sky, and if you do have a coincidence where they happen to be in the same place, that can result in a lunar or a solar eclipse. As these orbits are extremely well defined, we can actually predict when those eclipses will occur many years in advance.
While we're on the subject of the sun and the moon and making predictions of celestial movements such as eclipses, the heliocentric model has no ownership or precedence of being able to make predictions of eclipses. These are things that have been predicted for thousands of years by all kinds of cultures, none of which used a globe or a heliocentric model to make their predictions. In fact, most of them use a lunar calendar. And we can see from the observations we make that the idea that the Earth is a globe and spinning, and that the moon orbits the Earth only once a month or once every 28 days or so, and that the Earth is spinning to create day and night, is just one interpretation from, again, looking up into the sky, not seeing any measurable curvature across the surface of the Earth, not seeing any kind of spin whatsoever on the Earth, simply by looking up at the sky and using the sun and moon rather like we look at the hands of a clock.
What you've just seen is a good example of what they call the false equivalency logical fallacy. In this logical fallacy, a common element is found between two completely dissimilar and unequal concepts, peoples, or systems. For example, both Jesus and Hitler used very similar methods to attract followers, yet clearly they are not equal. In the current example, both the globe and the flat Earth model are models of what our Earth and universe looks like, but they are both clearly not equally valid. For example, on the globe model, we can navigate, we can use a sextant, we can predict sunrise and sunset to the minute at any community in the world. We can predict the exact location that boats will start to go hull down over the horizon, or what will and will not be visible at a distance. We can accurately predict time. Predictions that are made on the spin of the Earth come true. For example, objects weigh less on the equator than they do at the poles. This is borne out by experimentation. Contrast this with a flat Earth that can't even find the South Pole. Even what rules they do agree work on a flat Earth have multiple exceptions that must be made, and then exceptions must be made for the exceptions in order to make everything fit with what we observe in the world. The observations in the real world support the globe model. Observations on the flat Earth generate more excuses than accurate observations. In short, the systems simply are not equivalent, yet they are being held up as being equivalent and equally valid. Now, at this point in the original video, Phuket Word went on to demonstrate his total lack of understanding of long-range navigation and prove that a sextant will not work on a flat Earth. That is in Flat Earth Can't Science, Episode 4, Phuket Word Gets Lost. Now we're going to proceed on to his next video where he uses some carnival trickery and his special version of occasionally enforced rules of perspective to try and debunk an observation made by a globe earther. Now, as part of this, we're going to test your ability to critically think. I want you to look and see if you can pick out where the trickery occurs. Now, there are actually two experiments that were targeted by this video by Phuket Word. The first was an attempted debunk of Miles Davis. He's already been spanked pretty hard on this, but I think he's trying it again. To recap that observation by Mr. Miles Davis, this is a bridge in Scotland. Davis is on a hill at 210 meters. The top of that bridge tower in front of you is 210 meters. Lining up the observation height of 210 meters and the bridge tower at 210 meters, we see the 400-meter hills in the background are actually below the level of the bridge tower. You can see the linked video below, but this is irrefutable proof of a curved Earth. The actual subject of this video is this observation by baldy cats. This is Mount St. Helens here in the United States, and on the background on the left you can see Mount Rainier. The observation heights are listed there, and as you can see, Mount Rainier appears to be lower than Mount St. Helens. Like the Davis example, on a flat Earth, due to perspective, Mount Rainier should be higher than Mount St. Helens. The data is right there. I'll refer you to the excellent video for full explanation. Now I'm going to go ahead and let you watch Phuket Word's video on this. I want to see if you can find the shell game that he plays and the errors that he makes. Please listen carefully for the NLP techniques that we talked about earlier. He uses them frequently, as he tells you how this false data should be interpreted to follow his narrative. See if you can see what he does.
It's time to do some primary school science. I'm afraid it's necessary because there are school teachers out there who claim to know what they're talking about when it comes to perspective, and they are just out to deceive and keep us believing we are primates on a spinning ball. Although they might appear to be smart with their mathematics that they use, they are blinding you with deception.
Just a short bit of background. This is a 4th grade science text, and Baldy Cats is a teacher.
Here we've got 3 lighters. 1, 2, 3, they're all the same height, as we can see from this orthographic view. Now let's just imagine that these lighters are mountains. And we have our side-on view of these 3 mountains, which at the moment happen to be exactly the same height. And we know what happens when we change our perspective and we take, let's say, an approximately 45-degree angle view of the scenario. This one is closest to us, so it appears bigger. This one's further away, so it appears smaller. And this one's even further away, so it appears even shorter. Now, one thing to point out at this stage is that the camera's eye level, meaning parallel to the flat surface, is level to about halfway up. So what we know about perspective, and can be proven every single time, is that anything that is above your eye level will appear to sink down towards eye level as it goes off into the distance. Yeah?
Now I'm going to break in here for 2 reasons. First is to go over this photograph from Miles Davis again. Now, Phuket Word is actually talking about real perspective here. The other reason I broke in is I wanted to break his hypnotic tone of voice. He's using the NLP technique to try and lull you into an accepting frame of mind. It's the old, these aren't the droids you're looking for technique, but I want you to see the droids, so pay attention, please.
And every time we change our angle of view, our perspective, there are changes that occur in the apparent differences of height. Once again, we go back to this view. They all appear to be the same height. We go this way, and of course this one's very big now because it's very close, and this one's far away, so it seems smaller, and that one's even further away, so it seems even shorter. Yeah, and when we come around here like this, we can see a distinct difference. But when we lift the camera up and the camera's eye level is level with the top of the lighter or the imaginary mountain, then those mountains in the distance also appear to be the same height now. So when we have this kind of view and we have this kind of view, they all appear to be the same height. But between this perpendicular and straight on view, there will be a change due to perspective in the apparent height. Okay? Eye level, same height. Below eye level, they appear to get shorter and shorter. This is being used as a way to claim that things in the distance appearing to get shorter are going down a curve when they're not. But sometimes what happens is someone says, well, that mountain in the distance is higher than the mountain in the foreground. Let's make this mountain, or lighter, higher than this one. Okay, oops, let's check that. All right, there we go. Okay, this one is at the same height, and this one is physically higher, and we can tell from this perspective. But as we go around and we change our perspective, ooh, look what happens. We know this one is physically higher than this one, but this one appears to be taller because the camera's eye level is below the top. When we actually go to the top of this imaginary mountain, then maybe we will see the more distant, higher mountain. But, you know, maybe if we come far enough away, this would block that mountain. Yeah, you see? Ah, yeah, it's all about perspective, okay? So when someone shows you a view like this, with a short mountain in the foreground and a taller mountain in the background that appears to be shorter than this one, and then gives you a bunch of calculations, you know they are trying to deceive you and blind you with numbers and equations and phrases in the language of mathematics. When the reality is perspective and whatever angles and numbers and equations you want to include every time you move or change your position are what makes a difference. They know this. They finally sussed it out after being told for several years that perspective is the imaginary curve, and it's only now that these smart monkeys have managed to work out what it really is, where they were going wrong. So now they're doing everything they can to deceive and pretend that they're taking perspective into account. Yeah?
Boy, he seems to make a lot of sense there. But did you catch what he did? Let's see. Okay, so we're going to go through this experiment again with these AA batteries on my office table here. And I've got an insert there with an example from his video showing it's the exact same thing. So right here we've got the side view, 1, 2, 3. Each battery is exactly the same height, 1, 2, 3. Okay, here we've got a view of the batteries looking straight down the row from near the top. It also would be the same there about midway up, as you can see, and we've got the lighters from his video. Once again, everything lines right up, 1, 2, 3. Everything looks just the same and everything makes sense. Now we go to the critical observation. We've got our near battery, which is very short, is much taller apparently than the far battery, even though the far battery is physically taller. This is a very strong argument that the observation by Davis and Baldicats is only due to perspective. Now, how many of you spotted what he did? Now, if you're a flat earther looking to reaffirm your fantasy, you probably mirror this on your site. But we have to be a little more critical here. Well, the first obvious thing is that he is not drawing lines of perspective here. He's using the side view and showing the level of the top lighter and then the level of the far lighter. Notice that they are parallel to each other. There are no lines of perspective here. What's the other obvious thing that he did to try and trick you? Well, here's a hint. How many lighters are there? And how many did we start with? Weren't there originally 3 lighters? Let's see what happens when we put the third lighter back in and draw the lines of perspective. Here's our same view with the reference battery in the middle to allow us to draw an accurate line of perspective. Now, which one's the highest? You see, Phuket World actually knows about perspective, and he knows that we would spot this immediately. What's more, this observation by Davis and Baldicats disproves the flat Earth, because it's impossible for that far battery to appear lower than the near two. So basically, Phuket Word pulled a shell game trick on you. I want you to watch him do it. See what he does. Remember, the hand is quicker than the eye. He's very practiced at this. I suspect that he probably plays 3-card Monte. Watch it again and pay attention to the back lighter. We'll slow it down a little bit for you. So in his effort to debunk this rather good scientific observation, Phuket had to resort to this trickery. Notice the distraction of the book. Now, he switches hands. He's holding it in his left hand. He reaches over with his right hand, flicks the lighter, and using his hand as a screen, puts the second lighter up to set up this shot.
Don't worry about the numbers. Don't worry about the mathematics. Worry about the reality, about what we see. This versus this. Okay? It's very, very simple. And it's science. Thank you very much.